If you traveled 10,000 years into the future, what would planet Earth look like? Would most of its surface be covered in volcanoes, or would it be frozen in ice? What if you traveled even further, to 1 million years in the future? Would all of the oceans have evaporated, or would Earth have become one giant water world? Okay, now what about 1 billion years? Would there be any humans left, or would they have settled in other parts of the galaxy? Let's find out what would happen if you traveled 1 billion years into the future. Buckle up, because it's going to be a long, strange journey through time, and Earth as you know it is going to change beyond recognition. The first challenge: will humans even survive? Before we jump into what Earth looks like 1 billion years from now, we need to address a fundamental question. Will there be any humans around to greet you when you arrive? Let's face it, the chances of any humans being around 1 billion years into the future are pretty low. Several key existential threats face the human race, and if we want to be around in 1 billion years, we'll need to endure them all. We've seen how much we've struggled to come together just to survive a global pandemic. So how do we have any chance of enduring the much bigger threats of climate change, overpopulation, global nuclear war, killer asteroids and comets, natural ice ages, and the sun getting a whole lot hotter? The answer is that we probably can't, at least not on Earth. If humanity still exists 1 billion years from now, it won't be because we stayed here and toughed it out. It will be because we left, spreading out to other planets, other star systems, building a civilization that spans the galaxy. But we'll get to that later. For now, let's start our journey through time and see what happens to Earth along the way. 10,000 years. The Millennium Bug returns. Just under 10,000 years from now, we're going to run into a big problem. The year 10,000 Millennium Bug. In the year 10,000 in the future, software encoding the calendar year won't be able to handle dates with more than 4 digits. Remember the year 2000 bug? Yeah, it's just like that. Except hopefully we won't panic as much this time around. On the bright side, by 10,000 years in the future, genetic differences and traits between humans will no longer be regional. Traits like skin color, hair color, and facial features will be evenly distributed around the world thanks to global migration and intermixing. Maybe that will help us all get along better. Maybe not. Humans have proven pretty creative at finding reasons to fight each other. 20,000 years. Languages become unrecognizable. 20,000 years into the future, none of the current languages will be recognizable. English, Spanish, Mandarin, Arabic, all of them will have evolved so much that they'd be completely incomprehensible to someone from our time. Future languages will only contain about 1% of the core vocabulary words of their present-day counterparts. Think about it this way. The English we speak today is only about 1,000 years old. Go back to Old English from 1,000 years ago, and you'd barely recognize it as the same language. Now multiply that change by 20. The languages spoken 20,000 years from now will be as different from modern languages as modern languages are from ancient proto-languages. 50,000 years. A new ice age begins. 50,000 years from now will mark the beginning of a new glacial period for Earth, which will start a new ice age. Massive ice sheets will advance from the poles, covering large portions of North America, Europe, and Asia. Cities that exist today will be buried under kilometers of ice. At this point, Niagara Falls will have eroded completely into Lake Erie. The constant flow of water over the falls, carrying sediment and wearing away rock, will have pushed the falls upstream until they cease to exist as a waterfall entirely. The Great Lakes will be reshaped by this process. Interestingly, a full day on Earth will also increase by 1 second at this point. The moon's gravitational pull creates tidal friction that gradually slows Earth's rotation. The effect is tiny, about 1.7 milliseconds per century, but over 50,000 years it adds up to a full second. So there will be slightly more time for activities, not that you'll notice. 250,000 years. New islands, new threats. In 250,000 years, the Loihi volcano, currently an underwater seamount off the coast of Hawaii, will rise above the water to form a new Hawaiian island. Volcanic activity will continue building this island over hundreds of thousands of years, adding another landmass to the Hawaiian chain. By 500,000 years in the future, it's likely that an asteroid with a diameter greater than 1 kilometer will hit Earth. Unless we've developed the technology to prevent it, the resulting crater will be no less than 400 kilometers across. The impact will start fires all over the planet, throw enough dust into the atmosphere to block sunlight for years, and make the air unbreathable from smoke and particulates. Mass extinctions will follow. If humans are still on Earth at this point, this will be a civilization-ending event. 1 million years. Volcanoes, supernovas, and human evolution. In 1 million years, we'll likely have another supervolcano eruption, large enough to spew out 3,200 cubic kilometers of ash. To put that in perspective, it would produce enough lava to fill 3/4 of the Grand Canyon. This would be similar to the Toba eruption that almost wiped out humanity 70,000 years ago, reducing the global human population to perhaps 10,000 individuals. Out in space, the nearby star Betelgeuse will have exploded into a supernova by this time. Betelgeuse is about 650 light-years away, which is close enough that when it explodes, it will be visible from Earth even during the daytime. It might be as bright as the full moon, visible for weeks or months before fading. It won't be dangerous to Earth. It's far enough away that the radiation won't harm us, but it will be spectacular. If humanity has survived this long, we'll likely have settlements throughout the solar system by 2 million years in the future. Colonies on Mars, orbital habitats around Jupiter and Saturn, mining operations in the asteroid belt, research stations on the moons of the outer planets. This also means that if populations on different planets have remained separate without much interbreeding, humans may have evolved into other species, adapted to their specific worlds. Martian humans might be taller and thinner, adapted to lower gravity. Orbital humans might have weaker bones and muscles, but enhanced fine motor control for zero-gravity work. We might not even recognize each other as the same species anymore. Ponin. 10 million years. Continents start moving. By 10 million years in the future, geological changes become dramatic. A huge part of eastern Africa will break off along the East African Rift, forming a new ocean basin. The Red Sea and Gulf of Aden will expand as Africa literally tears itself apart. Eventually, everything east of the rift, including parts of Kenya, Tanzania, and Mozambique, will be a separate landmass, possibly a new continent, drifting away from the African mainland. 50 million years. Africa collides with Europe. In 50 million years, Africa will collide with Eurasia, completely closing off the Mediterranean Sea. What was once a sea will become a new mountain range, formed by the collision of two continents. This mountain range may include peaks taller than Mount Everest, pushed up by the immense forces of continental collision. Out in space, Mars will collide with one of its moons, probably Phobos, which is gradually spiraling inward toward the planet. The moon will be torn apart by tidal forces before it actually hits the surface, and Mars will develop a ring system like Saturn's. These rings will probably only last a few million years before the particles fall back to the surface, but while they exist, Mars will be beautiful to observe from Earth, assuming anyone is still around to look. 60 to 100 million years. Erosion and impact. In 60 million years, the Canadian and American Rocky Mountains will have eroded entirely. Mountain ranges are temporary features on geological timescales. Wind, water, ice, and time will wear them down to low hills and eventually to plains. In 80 million years, all of the Hawaiian Islands will be below water. The volcanic hotspot that created them will have moved on, and without continued volcanic activity to build them up, erosion and subsidence will pull them beneath the ocean surface. In 100 million years, an asteroid similar to the one that killed the dinosaurs 66 million years ago will likely hit Earth. An asteroid 10 kilometers wide will create a crater 200 kilometers across, trigger global firestorms, throw enough debris into the atmosphere to cause a years-long winter, and cause mass extinctions across the planet. If any complex life still exists on Earth at this point, and we'll get to why it might not, this impact will be devastating. 250 million years. Pangaea returns. In 250 million years, all of Earth's continents will fuse together again, forming a new supercontinent. Scientists call it Pangaea Ultima because it will resemble the ancient supercontinent Pangaea that existed about 300 million years ago. Pangaea Ultima will be massive, with one enormous landmass and one enormous ocean covering most of the planet. The interior of the supercontinent will be extremely hot and dry, a vast desert cut off from ocean moisture. Coastal areas might be habitable if any life remains, but the center will be a dead zone of extreme temperatures and no rainfall. But don't get too attached to Pangaea Ultima, because in 400 to 500 million years, it will separate again. Continental drift never stops. The supercontinent will break apart, and the continents will begin drifting away from each other once more, starting a new cycle that will eventually lead to another supercontinent hundreds of millions of years later. 500 to 600 million years. The beginning of the end. In 500 to 600 million years, a gamma-ray burst will likely occur within 6,500 light-years from Earth. Gamma-ray bursts are the most energetic events in the universe, releasing in a few seconds more energy than the Sun will emit in its entire lifetime. If a gamma-ray burst strikes Earth directly, it could damage the ozone layer and trigger a mass extinction. The radiation would sterilize one side of the planet and destroy the atmosphere's ability to block harmful ultraviolet radiation from the Sun. Around 600 million years from now, the Moon will have drifted so far from Earth that total solar eclipses will no longer be possible. The Moon's distance from Earth increases by about 3.8 centimeters per year due to tidal interactions. Over 600 million years, that adds up to a lot of distance. The Moon will appear smaller in the sky, no longer large enough to completely cover the Sun during an eclipse. More ominously, the Sun's increasing luminosity will have raised temperatures on Earth so much that it could halt plate tectonics movement. Plate tectonics requires water to lubricate the movements of crustal plates. Without water, the continents would stop moving, volcanic activity would decrease, and the carbon cycle that regulates Earth's climate would break down. 800 million years. Photosynthesis ends. In 800 million years, carbon dioxide levels will drop dramatically. This might sound good after all. We worry about too much carbon dioxide today, but for life on Earth, it's catastrophic. Plants need carbon dioxide for photosynthesis. As the Sun gets hotter, more rock weathering occurs, which removes carbon dioxide from the atmosphere. Eventually, carbon dioxide levels will drop so low that most plants can no longer perform photosynthesis. Without plants producing oxygen, free oxygen and ozone will gradually disappear from the atmosphere. Complex life on Earth will die. Animals, plants, fungi, anything that needs oxygen to survive will suffocate. Only anaerobic microbes, bacteria that don't need oxygen, might survive in extreme environments like underground caves or deep ocean thermal vents. Earth will become a dead planet, at least in terms of complex life. The surface will be barren, the atmosphere will be thin and mostly nitrogen, and the oceans, if any remain, will be filled only with primitive microorganisms, if anything at all. 1 billion years. Arrival at a dead world. And finally, we arrive at 1 billion years in the future. This is what you came to see. This is the Earth that awaits you when you step out of your time machine. The Sun's luminosity will have increased by 10%. That might not sound like much, but it's enough to completely transform Earth's climate. The average temperature on Earth will be 47 degrees Celsius. That's 117 degrees Fahrenheit. Hot enough that standing outside would be like standing in the hottest desert on Earth today. Except there's no escape, no cooler night, no relief. Our atmosphere will feel like a damp greenhouse. The heat will cause the oceans to evaporate rapidly. Water vapor is a greenhouse gas, which means more water in the atmosphere causes more warming, which causes more evaporation in a runaway feedback loop. Eventually, the oceans will evaporate almost completely, leaving just pockets of water at each of the poles where temperatures are slightly lower. When you arrive in your time machine, be mentally prepared to take in a planet Earth that looks nothing like the one you remember. The blue marble you left behind will be a reddish-brown, desiccated world. The oceans will be gone except for small polar seas. The atmosphere will be thick with water vapor and unbreathable. The temperature will be lethal. No plants, no animals, no forests, no cities. Just endless desert and rock and heat. The human race will be gone. Hopefully they're living their best life on some other far-off planet, having left Earth long ago when it became clear the planet was dying. Because of the intense heat, lack of water, and lack of breathable air, Earth will be completely uninhabitable. Conclusion: don't stay too long. So you probably shouldn't stay too long on Earth 1 billion years in the future. There's nothing here for you. No life, no water, no hope of survival without an advanced environmental suit and a lot of supplies. Instead, you should head out to see the rest of the solar system. Maybe you'll find your fellow humans there, thriving on Mars or in orbital habitats, having long since forgotten about the dead world they left behind. Maybe you'll find some other form of intelligent life that evolved after humans left. Maybe you'll find the solar system completely empty, with humanity having moved on to other stars entirely. But one thing is certain: Earth won't be home anymore. The planet that gave birth to humanity, that nurtured our species for millions of years, will be dead. It's a sobering reminder that nothing lasts forever. Not civilizations, not species, not even planets. Everything has an expiration date, including Earth. The good news is that we have time. 1 billion years is an incomprehensibly long period. Modern humans have only existed for about 300,000 years. Written history only goes back about 5,000 years. 1 billion years is long enough for entire civilizations to rise and fall millions of times over. If humanity can survive the next few centuries, if we can solve climate change, avoid nuclear war, deflect killer asteroids, and develop the technology to live on other worlds, then we have a future. Not on Earth, but out there among the stars. And maybe that's been the plan all along. Maybe Earth was just our cradle, and 1 billion years from now, we'll be thriving across the galaxy, having learned that our destiny was never to stay in one place, but to spread out and explore the cosmos. If you enjoyed this journey 1 billion years into the future, subscribe for more explorations of what awaits us in the distant tomorrow, and maybe leave a comment about where you think humanity will be in 1 billion years, extinct, evolved into something unrecognizable, or thriving across multiple star systems. Stay curious about the future.